All right, it's time to start talking about functions and methods. Now, for this video, we're not going to talk about functions too much. We're going to try as best as I can to really use the word method. But a function, first, a function is a chunk of code that you may want to use over and over again. Now, there's a bunch of rules of thumb that are associated with a function. One, a function needs to do one thing, but needs to do that one thing really, really well. That is the primary use of a function. I say, when do I use a function versus not using a function, just allowing to do it in the code? If you're going to do something more than twice, or actually more than once, it's probably best if you put it into a function because it's going to make your code much more usable and serviceable. Now, before we go into that in more detail, we actually will talk about methods in a second. I love close-up magic. I'm not a magician, but I love going to places and they'll have the close-up magician. And that close-up magician will not tell you their secrets. And they'll often say, you know what, I spent 6 months, a year, 18 months learning this given trick. Why would I want to share that with you? Now they'll tell you it's not magic. It's an illusion. It's something, but they spent a lot of time practicing it. If you begin to talk to them, you find out that a lot of the close up magic, the card magics and stuff like that, are really based upon a couple core principles, 50, 60 specific core principles. And once they understand those core elements, they can string them together and make other tricks out of them. And that is what a function does. It decomposes a program and puts it into small modular pieces so we can use them in other places in our program. Now let's really talk about methods because that's what this course is really about. The simplest definition is a function is a method is a function in a class, right? Simplest definition. A method is a function in or associated with a class. Now, if you're familiar with Python from other courses, Python does use object orientation. Python does use objects and classes and stuff like that, but you don't have to write Python in classes and objects. You can do it very sequentially, and you can still use functions. Java, not the case. Everything in Java is basically a class. We don't even call the individual files Java programs. We call them Java classes. So we put things in methods into those Java classes. So we keep the definition that a method is basically a function inside a class. And since all of Java uses class, that's why we use the phrase method for Java. But it's fundamentally the same thing. Fundamentally, we're decomposing, deconstructing these bigger programs, and then we take them and we build small blocks of code. Rule of thumb, that the block of code does one thing, but it does one thing really well. Well, that's not just a rule of thumb, that's a rule. In Java, it only can do one thing, especially when you start returning values. The other thing you want to keep in consideration is you don't want your methods to get too complex, too long. This is a rule of thumb. If your methods start getting past 30 lines of code, you might want to think about splitting up those methods. If that method is doing way too much, even though it may be returning a single value, but it's doing way too much to return that value, there's a more efficient way of doing that. So you start getting your methods around 30 lines of code, might be time to start splitting that. So now let's go up to my screen. All right, let's take a look at my screen here. And immediately you're going to think, man, Nick is really off the deep end here. Why do we have a Google Earth view of the continental United States? Well, I want to zoom in at Kansas real quickly. Sorry if I give anybody vertigo here. And we start seeing some very interesting patterns. This is Kansas, a lot of farmland and stuff like that. And we see these very interesting patterns of these squares and then circles within those squares. And if I zoom in just a little bit more, let me see if I can find a good example. Yeah, okay. if you see this little white line, this is an example of what they call pivotal irrigation. These little white lines, let me scroll this down here. These little white lines here are actually a sprinkler system. And when they pump water into the sprinkler system through gears and mechanisms, it basically pivots around the center and it waters this particular area. So if you look in the areas that are circles, those have been irrigated. They have water. The areas that are brown, they do not receive water. I'm assuming over in here, they're just rotating crops throughout the season. But this is kind of interesting, and keep this in mind, this pivotal irrigation in mind, as I go through these next two videos when we talk about geometric shapes. Now, are we going to be worried about pivotal irrigation? No, not really. But you're going to see some applications and that we will write that are associated with it. So let me go up to Replit. And inside Replit, I have a really bad program. I even called it Bad Main. It basically is its own Java class called Bad Main Java. If you really study it, we import math, and one of the reasons we import math is that we can use the pi constant. And here it says double diameter. So here it looks like we're finding the diameter of a circle based upon the diameter, finding the radius of a circle based upon the diameter. Then we're finding the area of a circle. The area appears to be pi r square. Then we print it out. Then we find the circumference. The circumference is 2 pi r. It's a mess. This is really a poorly written program, and I wrote it poorly for a very specific reason. This is pertinent information, and I've copied and pasted for two separate circles. Here's a circle with a diameter of 20, and here's a circle with a diameter of 5, and I had to copy it and paste it. I even created, this is really bad. What happens if I want to start including rectangles or triangles or other geometric shapes? What if I have not 2 circles, but I have 50 circles? Well, wouldn't it be nice to be able to figure out the area and radius and perimeter of all these different things without having to constantly copy and paste? So there's where we begin to use methods. Now, real quick recap. A method is a block of code that we basically just focus on, that we remove from other blocks of code, usually from the main method. We remove it, and a method does one thing, and it does that one thing really, really well. Okay, that's important, especially in Java. The method can either maybe just do a print method, maybe not return anything, or it will return a single value. And you'll see that more as we go through this demonstration. But one of the key issues with a method is associated with a class. But equally or more important is a method does one thing, and it does one thing really, really well. I want to clean up this program. I want to create a program that's going to use, actually, I don't want to just create a program. I want to create a project. And in Java, a project is a collection of programs and data files and a whole bunch of things here. So I'm going to start by saying, you know what? Let's start by creating a Java class, and we will definitely talk about more about classes and objects when we get to that particular. I'm going to create a Java file or a Java class that focuses on circular formulas. Now, to save some time, I already have a bunch of them, and it is empty. And through the magic of cutting and pasting, yes, I have things over at my other machine to kind of save time and stuff like that. I'm going to do a lot of cutting and pasting, but as I'm cutting and pasting, I'm going to be explaining. Since we know that circles rely upon pi, it's probably a good thing if we include pi in our circle formula. So let's start with an input, and we'll say input Java language math. And that's basically going to give us access to pi. Now, before we go any further, let's put a couple functions in there that will allow us to do things. Now, I'm going to put the main method in here. If I call it function, I apologize. I'm going to put the main method in here, and fundamentally, the main method is not going to do anything really really impressive yet, especially in this particular class. So I'm going to do a little magic of copy and paste. I'm going to put a main method. I'll line it up so it looks a lot better. All right. It doesn't do anything, and that's fine yet. I will explain what the main method is in more detail as we keep working on it. Now, I want to announce to, whenever I run this program, I want to announce to the world that I'm in this program and I will be leaving this program. I want to announce through main that I'm entering this program and I am leaving this program. Now I can easily just do a system out print line, spell it right. And I can say hi from main Java. And I can do the exact same thing with a system out print line bye from main. But I want to focus on creating these things using methods. So instead of doing it this way, I'm going to create two methods. I'll do a copy and paste. And make sure things line up so they look good. I have two methods here. One is a print hi method and the other is a print bye method. And they're really simple, but let me break them down. Like we've seen before, public basically means that this method can be used by any class in our project. Static means it doesn't create anything. Static is going to make more sense when we get into classes and objects. Void is important now. Before we just kind of pushed it off. We said, don't worry about it. We're going to get to it when we get to it. Now we have to talk about it. Void means that this method is not going to return anything. Okay? Remember, a method does one thing and it does one thing really well. So sometimes that method might just do a print. The other time that method may return a particular value. Because this method is referred to as a print method, we're going to call it print hi, it's not going to return anything. So I tell it void, which means don't return anything. These are parameters. Up here within these open and closed quotes is what we call parameters. Now I'm beginning to also begin to comment my Java code. We should have been doing that. As this Java code gets more and more complicated, you're going to see the necessity for commenting. And I'm using a technique called JavaDoc. It is long, verbose. It's a common technique. I strongly encourage you to investigate that on your own. But basically, for our particular situation, one line says what the method does. The other line says what are the parameters that are associated with this method. So this parameter name just is basically a string that I'm going to feed information to. It doesn't return anything. It's a void method. And it basically does that. System out print hi from the name that I pass that. Now, if I go down to the main method down here, I can now say print hi, and I'll send the name main.java. And I will do the exact same thing with a bye statement. I'll say print bye main.java. Or actually, this is circular formulas. Got main circular formulas. I'll change that here. Sorry about that. So when this program runs, when this class runs, Java's not going to ignore these methods, but it's not going to use them. It's going to be ready to use them. It's going to go looking for the main method and run things from the main method. Things do not get run from these other methods up here. So when I run this, it is going to compile it and put these methods away, but it's really going to run the code that's in here. It's going to ignore these codes up here and run the code here. Let's do that. All right, let's compile this code. I'm going to say Java C circular formulas Java. Give it a second. and it compiled it. Now let's run it. I can run it from the command prompt by just saying Java circle formulas Java. Give it a second. And it says hi from circular formulas, hi from circular formula here. So it went, it compiled all this, basically ignored these methods because they weren't being used, and then it hit the main method and said, okay, in the main method, you want to print hi, jumped up, it passed this value up to this parameter, and then it printed it out here, right? So these were what we refer to as print methods. They don't return anything, but they print. They do something for us. They do something really, really good. Now, I want to create this class to work with circles. There's many, many formulas that are associated with circles. We're only going to look at a couple of them, 2 or 3. Some of those formulas will use the radius. For example, the area of a circle is pi r, or pi radius squared. Other times they use the diameter. We want to begin to start thinking about how our users will use this code. We don't want our users to make decisions. So we don't want our users to say, well, if I'm doing this formula, I have to supply a radius. But if I use this formula, I have to supply the diameter. We want to make things as consistent for our users as possible. Now, I'm going to make a decision in my programming thought. I'm only going to tell my users, if you're going to use any of these functions, pass it the diameter of the circle. That's going to keep my coding consistent, but more importantly, it's going to keep my users consistent. So whenever my users need to pass an argument to a parameter, they're only going to pass the diameter. They don't have to worry about, and some of the functions I do it one way, other functions I do it another way. So let's create our first function, and our first function is going to be creating the radius. So let me do a copy and paste. Now we have some difference here. We still have public, which means any of the classes in this project can use this method. And I'll demonstrate that in a bit. It's not creating anything. It is a double, which means it's going to get information, but it's going to return a double value, right? So it gets information through its parameters, but it's going to return a double value. So we go up here and say, okay, and we're gonna name our method. We'll call it getRadius. We need a parameter. The parameter is d. So I send it the diameter, and then the calculation will be d divided by 2.0, because a radius is equal to half of the diameter. So down here, I basically return the radius. Now, let's test this. Before we go any further, let's test this. And I'm going to say double, and I'll call it radius down here. And I'm going to say radius is going to be equal to getRadius, and I'll send it a value of 20. All right, let's run this code and let's see what happens. Clear it first. I'm going to say Java compile circle formulas Java. And now I'm going to run it. Oh, I didn't print it out. That was silly of me. Wasn't planned. Let's try it again. And we'll run it this time. Okay, not too impressive. Basically, high from circle formulas. It got a radius, radius of 20, of a diameter of 20 becomes 10. So we know that function is working. Now, what's more important is, as we look at this function, it is available to anybody within this project. It doesn't create anything. That's what static means. And now instead of void, void means we don't return anything. We are going to return a double value here. We give it the method name and we give it a parameter if necessary. And we're going to say, okay, always send up the diameter. And then it will return the diameter. Let's copy and paste another method. And this one says public, available to everybody, static, don't create anything, void, meaning this method is not going to return anything. It's called print radius. It's a print method. And what this does is it accepts a diameter. That's here, that's parameter. And then now look here. We need to create or use a variable. And this is called a method variable, meaning that this method is only going to be used, this variable is only going to be used within this method. That's a good thing, because what if I need to copy and move this method someplace else? Maybe I take this method and move it to another class. So this keeps this method nice and tight. It keeps it all the things that it needs to be done inside this method. But lo and behold, look at this. R, which is a radius, is going to be equal to diameter divided by 2. No, I don't like that. That's hard-coded. I've already created a method. Why do you think I spent all this time up here testing and writing this method to ignore it? So what I'm going to do is, instead of saying d divided by 2, I'm going to say get radius, and I'm going to send it a d. So now this adheres to much better programming. It's a print method. I'm sending it the diameter. That was my decision, that whenever I work with a circle, I send it diameters. The first thing it needs to do is, for the area, for a radius, it has to divide the diameter by 2. But you know what? We created a method to do that for us. Now, you're probably saying, Nick, the radius formula is so simple. Why don't I just keep using it throughout my program? What happens when formulas are more complicated? What happens if you're testing different formulas? By keeping your formula in one location. My formula to determine the radius is in one and only one location. Every time I need to determine a radius, I go to that one location by calling that method. It's cleaner and it makes more sense. In this particular example, this example is not the strongest example in the world, but this example, replace radius with some other more complicated formula. Replace radius with a formula that you're testing that you may have to change quite frequently. By having that formula in one location, things are going to be smoother. So we have a get radius, we have a print radius. How about finding the area? So let me cut and paste. So I have a method here. It's a public method, available to everybody, doesn't create anything. It's going to return a double, and it's going to get the area of a circle, and the area of circle is going to be a double. Well, I'm sorry, the parameter is going to be a double, so it's going to retrieve a diameter. That's one of those consistency. So every time I call any of these functions for a circle, I'm always going to pass it a diameter. And the formula here is, to get the area of a circle, it's pi r squared. Well, again, now this might look confusing. Why am I assigning double here, this r here and here? Again, I'm using this as a method variable. It's going to, for this method, it's going to use its own r. This method, it's going to use its own r. So if I need to remove this method, move it someplace else, all the parts that are associated with method follows me. You'll notice now I'm using good code, because if I try to determine the radius, I basically say, go out and get the radius. And then I return the area. The area is pi times r, and it returns the value. All right, let's do a print method associated with area. All right. Public available to anybody. Static doesn't build anything. Void doesn't return anything. It's going to accept a double. It's going to accept a diameter, which is a double. It is, again, there's our old friend R here within the method. It gets the radius first and then basically prints out the area of a circle with the radius of R is, there's our formulas, right? How about circumference? Let's find out circumference. Go a little bit quicker now. Same general madness, right? Public static double, you give a parameter of the diameter, there's a double, get the radius. Perimeter circumference is 2 pi r. All right, let's do our print statement. All right, so that's going to print the diameter. Now, it might be a good thing to have a method that prints all the other information. Now, this is going to be a little tricky, and I'm going to copy and paste the whole thing all at once. Now, could we do every one of these system outs again? Absolutely. But why would we do that? Anytime we want to print the circumference of a circle, anytime we want to print the area of a circle, the radius of a circle, we've already done that. We've built the functions to do that. We don't want to repeat code, right? So this method is just going to call those other 3 methods. All right, so this print all method is going to print the radius. First of all, print all, its parameter is the diameter. Parameter is the diameter. And then it's going to feed that. It's going to push, it's going to make these calls to the print radius, print area, print circumference methods, right? It looks like a lot more work than that really bad program. And maybe it is, but think about what we can now expand upon it. This is really kind of ugly here. This is really ugly here. This, we have methods, we're calling them, but more importantly, if I need to make any changes, I'm very restrictive to where I need to make the changes. Once I create all these methods, and once I test all the methods and I verify that they work and they do what I want to work, I don't have to worry about them. Now, the only area of the code that I have to worry about is down here in main. All those methods are obfuscated. They're hidden from us fundamentally. Can you imagine a situation where you're working on a project with a bunch of people? You work on a project with a bunch of people and Alice works on the circles, Bob works on the rectangles, Charlie works on the triangles. They build their methods, they tell you what you need to pass to them, and lo and behold, it works. Now, let's run this program, but obviously we need some kind of information. I'm going to say print all. I want to print everything associated with a circle that has a diameter of 20. And just for cleaner output, I'm going to put a blank line in here and make sure. And I'm going to say print all for a circle that has a diameter of 5. That's exactly what I did here. It's exactly what I did here. But now look how clean my main method is. My main method is now doing my logic, what I want it to do. And it's doing that by calling the given functions. So let's compile this and let's run this. a lot cleaner, better coding. If I wanted to put more comments in there, this is a much superior method. You know what, Nick? Let's go back to Kansas. All right, so we're back in Kansas, and wouldn't it be nice if I created classes that were associated with squares? And squares are just a form of a rectangle. So it would be nice if I created a bunch of functions that are associated with a rectangle. How about if we kind of zoom back a little bit? Look over here. Kind of looks like Pac-Man is eating this person's farmland, but this is a triangle. Maybe I can create a bunch of methods that are associated with a triangle. Yeah. Now, going back to REPL, would I want to put that all inside the circle formulas? Of course not. Circle formulas belong to circles, right? Rectangle formulas belong to rectangles. Triangle formulas belong to triangles. So in the next video, I'm going to incorporate all these pieces, parts together. So that being said, we learned a lot. Let's go on to the next video.